Have you ever read Arthur C. Clarke's Fountain of Paradise or watched Passengers, a film starring Jennifer Lawrence and Chris Pratt? For those who have, and for those who haven't yet, notice some of the underlying technological concepts that can be found in both. For one, Fountains of Paradise is a science fiction novel from 1979, featuring an engineer with the ambition to build the world's first space elevator. As for Passengers, it follows two humans who wake up too early from suspended animation, aboard an intergalactic spacecraft on its way to colonize a new planet. The concept to notice here is that the spacecraft is autonomous. While the crew is also in suspended animation, it is a computer that makes the decisions and repairs necessary to keep everyone alive. Now imagine bringing these two fictional concepts together, a space elevator infrastructure infused with some artificial intelligence to keep things running autonomously. Both are relatively new technologies, only emerging in the last few decades, but the implications of such a partnership for safety and for cost reduction related to space exploration cannot be ignored. Advancements in the testing, in the implementing, and the operational phases of a space elevator can all be argued when bringing AI into the picture. Hi, my name is Henrique Moreira, and I am an honors pure and applied science student in my final semester at Vanier College in Quebec, Canada, and a future mechanical engineering student at McGill University. This video presentation is for the 2024 International Space Elevator Consortium, or ISEC, Academic Challenge, which is co-sponsored with the National Space Society. For this challenge, two prompts were given. The first dealing with identifying the major strengths of the Green Road to Space, and the second, utilizing AI technologies for space elevator missions. As per the introduction of this video, I chose the second challenge and wrote a paper titled Space Elevators, AI-Enhanced Operations and Maintenance Leading to Research of Advanced Interplanetary Travel. This video will be split into two parts. In the first, I will discuss why I chose to take part in this challenge, and in the second, I will briefly present my paper. To start things off, I am proud to say that last year, in 2023, I partook in the first ISEC Academic Challenge and was awarded first place for my research paper titled Space Elevator Applications of Geostations and Microgravity. The video I made for that challenge, as well as the videos for the second and third place finishers, can be found on ISEC's website, isec.org. I was introduced to the challenge and the concept of the space elevator by my first semester mechanics professor at Vanier, Stephen Cohen. He had done his master's thesis on the dynamics of the space elevator, and he decided to share his passion with the class. I was, however, the only one who seemed to be deeply intrigued by this concept. An elevator to space? That's the type of thing that you see in science fiction movies, not in real life. I had never thought that this was a tangible concept. I got home that evening and started doing some research, and what I found was amazing. This whole idea of being able to get things to space without using rockets was crazy. Not to mention the possible versatility that this infrastructure would have on space research and even on launching craft through the solar system and beyond. The implications that this technology has would change the way that we interact with space and how we see space travel. All of that to say, I was hooked. There are still many technological challenges that need to be overcome before the space elevator is a reality, one of the main ones being the tether material. And as an aspiring future engineer, I can see myself working on this project on helping further our understanding of the space elevator and all the technologies that come with it, and hopefully making the space elevator a reality. With the help of my professor, I came up with the idea for my first paper, looking at geostations and the microgravity considerations that come with that, and I submitted an abstract, and from there, submitted a paper, and then a video. I learned so much from writing that first paper. I learned general knowledge on the space elevator, how to write a research paper, and I even learned how to edit and make a video because of this challenge. The space elevator community hooked me in, and they were very welcoming. So when I heard that there was another challenge this year, I jumped at the opportunity to contribute again. To contribute, but also to deepen my own knowledge on space elevators and to learn new things. When I saw that there was a second challenge, I didn't skip a beat and started thinking of which challenge to choose. In the end, I chose to write about the implementation of AI within the space elevator infrastructure. One of the greatest tools at my disposal in helping me make this decision and in writing my paper was the ISEC body of knowledge, and I'll explain why. The space elevator community and industry are relatively small, and not many people outside of it are working on this idea, so it becomes harder to find credible sources and accurate information online. With access to this ISEC database, there was so much information that I could access to familiarize myself with the space elevator and the types of research that have already been conducted and research that have been proposed. I noticed that there is quite a bit of papers already out there on the space elevator being a green road to space, but essentially none on the topic of AI, when related to the space elevator. At least not publicly, this idea hasn't been looked at. And it makes sense because AI is an emerging field, and it's only very recently that it has taken off. I thought this to be the perfect opportunity to write something innovative. I don't have the experience or resources to conduct specific research on the subtopics that I discussed in my paper, so the main purpose of it was to form a baseline for others to work off of. And here's a quote from my paper. While this paper does not provide calculations or engineering design concepts or specific details into operations, a broad overview of certain phases in the space elevator development will be looked at in conjunction with AI, with major important points looking at autonomous operations and predictive maintenance and prevention analysis. This paper presents initial arguments that favor and encourage the integration of AI into the space elevator infrastructure and can be used as a template to foster further in-depth and specific research on the discussed topics. Establishing a continuous and stronger human presence in space is essential to study and explore the cosmos. Methods of reaching space are limited to rockets, at least for now. Newer reusable rockets reduce overall payload deployment cost and waste, but still consume large amounts of fuel, which is detrimental to the environment and is still overall costly. In the late 20th century, the concept of space elevators became more widespread as developments in technology continued to advance. Benefits in cost reduction of payloads to orbit, in potential research opportunities, and in providing energy requirements for interplanetary travel are all factors that make the space elevator appealing and a worthwhile investment. In the same period, when space elevators started to be researched, artificial intelligence started to appear. In today's world, AI is taking industries by storm. Machines that can think, compute complex calculations, and perform intricate tasks autonomously are of great value. While AI still doesn't have the same degree of creative problem-solving skills that humans have, it can still bring numerous benefits if implemented correctly. AI provides advantages in multiple phases of space elevator design and implementation processes. There are advantages in the design aspect, in the systematic day-to-day operations, and there are even advantages with interplanetary travel. AI-enhanced software and computer simulations will be crucial in the development and construction phases of erecting the space elevator infrastructure, and this is the point where we are currently at. Daily operations will also be enhanced by AI, which will see overall benefits in safety, cost reduction, and time optimization. By incorporating AI into autonomous operations, the system will be more adaptable and dynamic. This will be possible with the use of sensors, networking algorithms, and real-time and continuous data processing. The space elevator infrastructure will then benefit from predictive maintenance and data-driven anomaly detection, increasing structural lifespan in the hostility of space. The third point is that AI and the space elevator will be useful with in-field testing of planetary habitats and spacecraft to test design viabilities to sustain human life. One major concern in space exploration is radiation protection. The combination of the space elevator with AI technologies and pairing that with robotics will help in keeping humans as safe as possible during explorations of the moon, of Mars, and beyond. Ethics of AI are complicated, and certainly some compromises will have to be made. While this paper does not dive into the ethical implications of using AI, they must still be considered. The space elevator is expected to be the safest means of reaching outer space, so will integrating AI into the infrastructure make people have second thoughts? Will the potential advantages outweigh the moral dilemmas? Maybe AI should have control only of certain operational parameters and not the entire system. The advantages and disadvantages will have to be weighed to set predetermined limitations, if any. With this paper as a baseline, further research should be conducted in these different aspects and fields to confirm if there is indeed such an advantage in using AI within the space elevator infrastructure. Once the system is in place and risk has been mitigated, our exploration and colonization of the cosmos can finally begin. And in the words of author Arthur C. Clarke, the moon is the first milestone on the road to the stars.